Evaluating multiple choice question exam in SPSS and Excel by performing item discrimination analysis to determine which question can distinguish between high performing students and low performing students, and sort out the question according to their difficulty levels, whether they are very difficult questions or easy questions, using item difficulty analysis or p-value analysis. Analysis of multiple choice questions exam quality using item discrimination based on two methods: Kelly's equation method and point biserial correlation coefficient. Both methods will be explained and described in this video. Data taken from exam result will be used to calculate the item discrimination in both SPSS and Excel software. Analysis of multiple choice questions style exam quality by calculating the item discrimination in SPSS and Excel on data extracted from student test results using Kelly's method. Item discrimination, abbreviated ID, is a method proposed by Kelly in 1939. It is a measure of whether an item, which is a question in this case, distinguishes between students who learned the subject content well and students who did not. The measure is based on the comparison of performance between excellent and poor students in the exam as a whole. The item discrimination is calculated by arranging the student total score from the test in a descending order. Group the students based on their scores into upper group and lower group. The upper group contains the top 27% of overall scores, and the lower group includes the lowest 27% of overall scores. Count the number of the correct items in the upper group, and then count the number of the correct items in the lower group. Then subtract the correct questions in the bottom group from the correct questions in the top group. Then use the Kelly's formula to calculate the item discrimination as given here. The ID equal to upper group minus lower group divided by 27% of total students, i.e. calculating the upper group proportion and the lower group proportion and subtracting them to get the ID. An ID percentage also can be calculated by multiplying the ID product with 100. Now, the item discrimination values range from -1 to +1 based on the equation of Kelly's. The outcome of the calculation have a range of -1 to +1. Positive value of +1 indicates that the item is discriminating between high performer and low performers, and +1 indicates a perfectly discriminating item. Zero value means that the item is not discriminating between high performers and low performers. On the other hand, negative value of -1 means that the item discriminates perfectly, except that low performing students answering item correctly and high performing student answering it wrongly. As shown here in the table, the range for the ID value is listed, and the items are classified as either bad item when the ID value is from 0 to 0.24, that is based on Kelly's formula. Good item when the value is between 0.25 to 0.39. Excellent item when the value is between 0.4 and 1. If the ID value is minus, then the item is very bad and it is recommended to remove and exclude the item from the exam or the test. Item discrimination analysis based on Kelly's equation to evaluate multiple choice exam questions in SPSS and Excel using the formula item discrimination equal to upper group minus lower group divided by 27% of total students. Item discrimination analysis in SPSS based on Kelly's equation. The analysis will evaluate and identify multiple choice exam questions that are good or bad in discriminating between high performing students and low performing students. So this analysis is only designed for multiple choice questions, and the analysis is based on an equation generated by Kelly's to determine the item discrimination or the question discrimination. And the way to do that is to calculate the total scores for each individual participant achieved in an exam, and then group the student into an upper group and a lower group. The upper group contains top 27% of the total score, and the lower group includes lowest 27% of student total scores. And then proportion can be calculated for the upper and the lower, and a percentage can be generated for each individual item or question. And the value for the item discrimination can be from -1 to +1. Here in this SPSS data view, I have a result from exam and the test for 20 students participated in this exam that included in it 20 questions, 20 multiple choice questions from 1 to 20. And each individual student answered the multiple choice questions, and their answers are recorded as either 0 or 1, given a value of 0 or 1. 0 represents wrong answer, 1 represents correct answer. And from those 20 questions, we aim to determine which one of these questions are good questions and which are bad questions, in distinguishing between excellent students and low performing students. And to do the item discrimination analysis, it is a multi-step. The first step is to calculate the overall mark or the total mark achieved by each individual student, i.e. to add up all the correct answer recorded by each individual student, add them up and generate a new variable, call it total score. And to do that, we click on transform, compute variable. In this new window, I'm going to generate a target variable, call it total score. And in the total scores, I'm going to add all the values within each individual cell together. So i.e. add all these multiple variables for each individual student together to generate the total or overall mark. So we need to use the sum function in this case. And the sum function, to get the sum function, click on all, scroll down to statistical, and then click on sum, drag the sum command into the numeric expression. A numeric expression, the sum is followed by a bracket. So we need to enter or transfer each one of these questions or variables into the bracket or between the bracket and separating each question by a comma. So if you click on the first one and then add a comma, click on the second one, transfer, comma, and then third one, and so on. And since we have here 20 exam questions, I had already generated these questions labels in Word document, type them, and I'm going just to select them and copy them and then insert them or place them in between the brackets. So if I delete that, add the bracket again and Control V or paste. So all the 20 variables have been placed in between the brackets separated by a comma, and this will instruct the software to add all the values for each individual student, to add them up together and generate a new variable called total score. If we click on OK, again we'll see here that a new variable is generated called total score that has in it the overall mark achieved by each individual student. And I'm going just to edit the column a little bit by removing the decimal point and making it 0, making it at the center, and then since it is a mark and this is a scale, it's measured at a scale. And then I'm going to reduce this, keep this up to 66, so to reduce the column. So now to continue with the item discrimination analysis, we need to rank those overall mark or scores in a descending order from high to low. So we're going to click on data, sort cases, and we are going to sort the cases by the total score and in a descending order from high to low. Again, as we can see here, the data are rearranged that we have the highest score achieved by student are 17 out of 20 and the lowest is 8 out of 20. The next step in SPSS is to rearrange the data to be able to manage to calculate the upper group and the lower group. So we are going to use a function called transpose, in which we transpose these questions from being in a column into a row and swap the students' numbers and IDs swap them from rows into columns. So it is a reciprocal swapping. So if we click on data, scroll to transpose, and then we are going to transpose all the variables with even the total score into the box of variable, and we're going to name the variable, move the student ID into name variable. And if we click on OK, a new window appears showing that the questions has been transposed into rows and student IDs had been transposed into columns. Again, as this is for question number 1, 3, 9, 19, and 2, similar to the original 1, 3, 9, 19. It's just only it has been transposed. I'm going to do a little bit of editing here as the width of the column is large, so I'm going to reduce it a little bit to do a little bit of editing. So I'm going to change first of all the decimal into 0 for the copy for all the data we have here, for the value of the value or the scores within each cell. And I'm going also to change the column width as it's too high for 12, so we'll keep it at 6, give it a 6, and this is also 6. And see if I can copy it, and if I can drag it and change it for all, if I click Control V, again it has changed the column to 6, number 6, and again align them into the center, so keeping the data within the center of the cells. And for measurement, we're going to change that into scale. For all the data. So when we look at the data view, it is much neater and much better. We could reduce it more, but that's more than sufficient. Again, if we look at the total score, the order and the rank is kept also constant, hasn't been changed since we have done the ranking. So now we have first of all calculated the total score, ranked the data, and then transposed the data. The next step is to group these students into upper group and lower group and calculate the proportion in each. And for the upper group, it should contain top 27% of the student total scores, and the lower group lowest 27% of the total score. And since we have here 20 students, and if you use a calculator, though we don't need a calculator, it's just only we have here 20 students, and we need to generate a group that has 25%. So we'll multiply that by 27%. 27%, that will generate 5.4. So we will convert that to integer. So we will put in the upper group 6 scores, overall scores from 6 students, and in the lower one overall scores from 6 students, again in the low performing student. So in this case, so we're going to generate upper group that includes 6 overall grade from 6 students, and the lower one overall grade from another 6 students that are performing poorly. And the way to do that is to generate again here a variable, call it upper group, lower group. So compute variable, generate a target variable, call it upper group. And the upper group, again, we can see here the order is and the rank is kept in place. So K1, as we can see here, is the highest mark or the highest total score here. The first 6 has the highest total score, so we're going to select 6 from K1, 1, 2, 3, 4, 5, 6 up to K4 here. So what we will do here is to click on brackets here, move the first value from the variable K1, and then add a plus sign, then add the second one, and then another plus sign, a third one, a fourth one, a fifth one, a sixth one. So we have here top grade or top overall scored from the top performing student. So this is the upper group, and we're going, since we have selected 6 students, divide that by 6. And if we click on OK, a variable generated here for the upper group for all the 20 students and the 20 questions. Now, to generate the lower group, we're going to do the same thing, but we're going to select the lowest 6 scores. So here are the lowest 6 from 1, 2, 3, 4, 5, 6. So starting with 7, moving 7, adding plus sign, and then this variable, plus sign, this variable, and then the next one. We haven't moved the 11th, and then we move the other one, and then the next one, and finally the last one. So we have here 1, 2, 3, 4, 5, 6 variables moved into between the bracket, and we need to add them up and then divide them by 6 to calculate, to generate the lower group. So here we are calculating the lower group, and if you click on OK, and again another variable is generated called lower group. The next step in generating and calculating the item discriminating IT is to subtract the value from the lower group from the upper group. And again, to do that, we click on compute variable, and I'm going to reset that and call it ID. And instead of retyping the whole thing, you just click on upper group, put the minus sign in between, and then lower group, and then click on OK, and ID or this item discrimination is generated here. We're going to ignore the value for the total score from our calculation, but what is genuine here is that this is the ID score, and the ID value should be between -1 to +1. So we could see 0 value here, and as we can see here, a 0 value, and a 0 value here and a minus value here and a positive value of 0.5. So if we take the first example here or the second one, minus 0.17. Minus 0.17 indicate that there is something not correct with the question. The question is, in this question number, let's say which question is this? Question number 2, low performing students are answering the questions correctly and high performing students are answering it wrongly. So this question has to be removed from the exam as it is not discriminative. It does not distinguish between high performing and low performing. Now the other thing is that also the question number 3 has a value of ID value of a 0, and that is indicate that this question is not discriminating between high performing or low performing as they both scored the same on this analysis, ID analysis. Again, the same thing for question number 4. If we scroll down here, again, this is a question number 16, and if we show from question number 16, it has a positive value and it is 0.83. This is a very high value, which indicate that this is a very good question, that it can discriminate between excellent students and poorly performing students. So anything, the rule for ID analysis, the rule for it that anything above 0.25 up to 0.39 is considered to be a good question. Anything above 40%, 0.4 and above is considered to be a extremely good question. So this question is extremely good. This question, again, this question, though it is positive, but the score or the value for it is 0.17, which is less than the standard. The standard for classifying questions has to be above 0.25 and above to 0.39, but in this case it is below 0.25. Thus this question is a poor question in discriminating between high performing and low performing. So this question is poor questions. This question is a poor one. This one is a good one, very good one, very good one. This is good. This is bad one. This is good, very good, very good, good, and so on. So this is the way to do item discrimination analysis in SPSS for a multiple choice questions, and it is of a great benefit and use for those who designing an exam or an assessment for students and want to evaluate the power of discrimination of the questions and ability of the questions or the item to discriminate between high performing and low performing students. The way to do that is, one of the way to do that is to do an item discrimination analysis based on the formula formulated by Kelly's equation. So the way to do that is to rank your data into according to the overall scores from high to low, and then in SPSS rank them, first calculate the total, then rank them, then transpose your data, and then calculate the upper group proportion, lower group proportion, and then subtract them from each other to generate the ID. We could also, in addition to calculating the ID in this way, we can also generate an ID percentage. The way to do that is to go to compute again, and we are going to call it percentage. And to do the percentage is to select the ID, drag it here, and then multiply that by 100 to get a percentage for the item. Again, as we can see here, this item is 83% discriminative. So this is the way to do item discrimination analysis in SPSS using Kelly equation. Using Kelly's equation in item discrimination analysis to evaluate multiple choice exam questions in Excel, to identify questions that are good in discriminating high performing students from low performing students, and to classify the questions as either a good question or a bad question, following the equation of item discrimination equal to upper group minus lower group divided by 27% of the total students. And we're going to perform the analysis in Excel. Here I have a data from an Excel sheet from exam results for 20 students answering 20 multiple choice questions from question number 1 to question number 20, and the score for each question is recorded as either 0 or 1. 0 is the wrong answer, 1 is the correct answer. So here we have a categorical data, dichotomous data, two possible categories, 0 or 1. And we want to determine the item discrimination for the 20 questions, to determine which question of these are good and which are bad based on the analysis. And the first step to do the item discrimination following the equation proposed by Kelly's is to calculate the total score or the overall mark achieved by each individual student. So we are going to generate here a column and we call it overall mark. And to calculate the overall mark for each individual participant, we need to add the score from all the questions from Q1 to Q20 all together. And the way to do that, click on the cell here, insert equal sign, then type sum, select the sum formula, and in the sum formula drag the range of the data to calculate the sum from Q1 to Q20. A value is calculated, 17. The grade or the mark, the overall mark for the first student is 17. And to calculate the rest, we just need to drag and hold and drag the value to the last student. So to auto calculate and auto fill the value for the over mark for each individual student. So we've calculated the overall mark. The next step in item discrimination is to arrange or rank those overall mark from high to low, from descending in a descending order. And the way to do that is to click on the data itself, select the whole data, and then click on sort filter and use custom sort. In the custom sort, make sure that this my data has headers is ticked, and we're going to use the column which is labeled overall mark, as this is our reference for doing the item discrimination analysis and a reference for ranking the data from high to low. And we're going to rank the data in the order of the largest to the smallest. If we click on OK, again we can see here that the software has arranged the data from the highest to the lowest. So the lowest score by students was 8 out of 20, and the highest is 17 out of 20. Now, following the arrangement of the overall scores in descending order, we need to generate the upper group and the lower group. So we're going to type here upper group, lower group, then ID for ID discrimination, and then ID percentage. And to calculate the upper group proportion and the lower group proportion, we're going to use the ranked value on the overall mark. And for the upper group proportion, we need to select the top 27% of the total student who achieve total marks. And for the lower group, select the lowest 27% of the total score. So student who scored lowest. So we have to generate two groups, and the number of the student to select will be equal to, if we have 20 questions or 20 students, and we want to arrange them into upper and lower group, and we want from the upper group to include 27%, then we multiply that by 27 to get a value of 5.6, which will be approximated to 6. So each group, upper and lower, each one of them will have 6 students in it. The scores for the 6 students for the upper and the lower group. And to calculate the upper group values, and I'm going here just to highlight this, divide these groups, this data into upper and lower. So if I select the first top 6 students and label them, give them a label of green, as this is the upper one, and the lowest group 6, select from it as lowest 6 students. I'm going to keep it red. Now, what we want to do here for the upper value, we need to insert the equal sign and then type sum and select the sum formula. In the sum formula, we are going to select the first 6 values here in for Q1, close the bracket, and then open another bracket and put the sum formula in a bracket, and then divide that by 6 since we have 6 students. So this is the way to calculate upper group proportion. If you click on enter, the value is generated. And we're going to do the same for the lower group. In the lower group, we're going to insert the equal sign and then type sum. And then we are going to select for question number 1, the 6 values, the lowest 6 values here, close the bracket, again, doing the same thing, put the sum formula with the value in brackets, divide that by 6 as the lower group has 6 students in it, press enter, a value has been generated. Now to auto fill and auto calculate the value for the rest of the group of the questions from Q2 to Q20, we're going to select, select the first row, drag it to calculate and autofill the value for the upper group, and do the same thing for the lower group, select and auto and drag to the last question number 20, and a value is generated for the upper and lower group. So here we have now upper group and lower group, and the next step to determine the item discrimination is to subtract this upper group from the lower group from the upper group. And the way to do that is click on insert, click on the cell, insert equal, select the first value here from the upper, then select, then put the minus sign, and then select the lower group, and then click enter. a value is generated for ID there. So this is the item discrimination for question number 1. Again, drag and select and drag to autofill and auto calculate for the rest of the questions. So here we have the value for item discrimination for the 20 questions. I'm going to decrease the decimals to make it a little bit by clicking on cell format and then number decimal. We're going to make it, change it, or make it, keep it 3, or even I'm going to change it to 2 to make it much easier to compare. Item discrimination value range from -1 to +1. A very good question. Good question has a value 0.4 or greater. A good question has a value of 0.25 to 0.39. And the bad question had a value of, or a value less than 0.25. And also ID value can be 0, or even it can be from 0 to -1. So those are all the possible range of value from -1 to +1. In the first cell here for question number 1 for the ID value is 0.33. This is a good question, as it can discriminate between high-performing student and low-performing student. The second question has a ID value of 0. 0 means that the question is not discriminating between high-performing and low-performing, so this is considered to be a bad question. So 0 indicate the question is bad, and 0 indicate the question is bad, and question number 4 also. So question 2, 3, 4 are bad questions, and they ought to be removed or excluded from the exam, or rewritten in another way that the ID for it will be higher. For this question number 5, the ID is 0.5, which is really a very good value. And this question is very good as it is greater than 0.4. And this question is very good in discriminating between excellent student and poor performing student. In this also, ID value for question number 6, the value is -0.17. This question is discriminating between high performing and low performing, but the low performing students are scoring the questions correctly, and the high performing students are scoring the question wrongly. So this question ought to be removed from the exam, as it is not discriminating, and omitting it from the exam is the best way to get rid of it. Others value here, we can see here there is a question which is number 16, has a value of 0.83. This is a very good question, in fact an excellent question in discriminating between high and low students. Question number 19 and 20 and question number 13 has an ID value of 0.17, which is below the range here. Anything less than 0.25 is considered to be a bad question. So this one and this one and this one is a bad question, ought to be removed from the exam, and this one -1 is also ought to be removed from the exam. These 0 value for the ID are bad questions, that they do not have the power to discriminate between high and low performing students. So this is the advantage of using item discrimination analysis based on the Kelly's formula, as it will permit identifying and evaluating questions and determining which questions are good, which are very good, which are bad, to remove from the test. Here, as we can see, out of the 20, 1, 2, 3, 4, 5, 6, 7 questions out of the 20 questions for the multiple choice for this exam are a very bad questions that has to be removed from the future exams. So this is the way to do an item discrimination analysis in Excel. First you have to calculate the overall score, arrange the overall scores in ranks from high to low, and then group the student into upper and lower group and calculate the proportion in each group, and then determine the ID value for each question. We could also do a ID percentage by inserting in this here equal sign and then selecting this and multiplying, selecting the ID value, multiplying it by 100 to generate the percentage of the ID, and we auto fill and auto calculate for the rest of the questions, and also we can reduce the decimal point here to something manageable and easy to recognize. So this is the benefit and the advantage of using ID for assessing multiple choice exam questions. Item discrimination analysis in SPSS and Excel for multiple choice question exam or exams using point biserial correlation coefficient. Item discrimination. Item means a question or refers to a question. Item discrimination assess the exam quality, assessing each question in exam sheet as either good or bad question. It does differentiate between students who have mastered the subject content from those who have not. It does determine how well an item is discriminating between good and poor students. Point biserial correlation coefficient assists the educator or educators to identify good or bad test questions. So the coefficient is one of the item discrimination index. It does measure the discriminating power of an item or a question. It is a method of measuring the relationship between student total exam scores, continuous variable from 0 to 100, and students item mark or score, dichotomous variable. Dichotomous mean two categories, correct or wrong answer. It does measure the strength of the relationship between two sets of data. So here in this case we have two variables. We need to correlate two variables with each other. One of the variable is continuous, such as the total mark, which is in percentage from 0 to 100, and the other variable is categorical, two categories, correct or wrong answer. The test, statistical test, the point biserial correlation coefficient, does measure the direction of the relationship, and it does calculate the significance of the relationship by producing a p-value. A p-value less than 0.05 indicates significant relationship. P-value greater than 0.05 indicates non-significant association. Now, the statistical test for point biserial correlation coefficient generates a value or values, and these values range from -1 to +1. +1 indicate a perfect correlation, positive correlation. -1 indicate a negative correlation, a strong one. Now, positive value of the coefficient indicates that the learner who answered a given question correctly also have a high score on the overall exam, and those who answered the same questions wrongly have low total mark in the test. A high positive value indicates that the question is discriminating high performing students from low performing students. Negative coefficient value means a high performing students are getting the answer wrong and low performing students are getting it right. In this case, remove the question from the exam paper. However, if the coefficient value is 0, that means the item or the question is not discriminating between students. So it's worth changing it or modifying it. In this small table, any value of point biserial that is greater than 0.4 indicate that the question is very good, and a value of 0.25 to 0.4 suggests a good items. Fair item have a point biserial value of 0.15 to 0.25. Any question that have a value of point biserial of less than 0.15, then it is a bad question or a bad item that worth modifying or omitting from the exam. Here in this table shown an exam result for 15 students answering 15 questions and multiple choice questions, and each question is recorded, the score for it, as either 0 on 1 is correct answer, 0 wrong answer. To perform biserial correlation coefficient statistical test perform the statistical test to generate the coefficient or calculate the coefficient, we first have to calculate the correct answer that each individual student has achieved, and then by adding all the questions scores for each individual student together, divide them by the total number of questions, in this case 15, and then multiply them by 100 to generate the total mark or total score or the percentage of the total mark as it is given here in the blue marked values in the column labeled as mark. So for in the point biserial correlation, once the total mark is calculated, The test is performed and the test will correlate each specific questions, the value in each questions, the scores in each questions with the total mark as shown here in this again slide. To calculate the R, which is the coefficient, or to execute the point biserial correlation statistical test to generate the coefficient, take every question with its value and scores 0, 1 and correlate that with the total mark for the whole student. And we do this for every question or every item to generate specific R value for each question and the P value for that question. This is how it is done in a statistical package or software. In this slide, this is a scatter plot showing a correlation between wrong and correct item, an answer wrong and correct for question number 5, and as we can see here in the y-axis is labeled as exam mark from 0 to 100, and on the x-axis it is labeled from 0, 1. 0 means wrong answer, 1 means correct answer. As we can see here, most of the students that who answered question number 5, item number 5, tend to have higher overall exam mark compared to those who had answered the question number 5 wrongly, tend to have lower total score or total mark. So this question 5 from this scatter plot can be considered as really a good questions. It can discriminate between the high performing students and low performing students. The next slide shows item analysis using the point biserial correlation coefficient either in SPSS or in another package software called Excel. As we can see here, for each individual question, there is a value calculated for point biserial value calculated and a p-value for question number 1 to question number 15. Again, here we have questions with their point biserial value and p-value. In the red labeled scores question number 1, we see that the value is negative and it is not significant because the p-value is greater than 0.05. Again, this question number 1 indicate that higher performing students are answering this question wrongly and low performing students are answering it correctly. So this question is a very bad question that need to be removed from the exam as it is negative. If we look at the question number 6, which is labeled yellow, we can see the value for the coefficient or the R is close to 0 and the p-value is very high. So this question is not discriminating between high and low student. So it is close to 0 and it's considered to be a bad question and it's either required to be modified or omitted from the exam. If we look at question number 11, 12 and 13, we can see that the R value is very high, 0.51 for question number 11, and the p-value is less than 0.05. So this question number 11 is a very good question in discriminating between students. So it is classed as or categorized as a very good question. Again, number Q12 also a good question, as it is the value for it 0.33 and the p-value less than 0.041. And the same thing for question number 13. It is, we can call it a very good question, as the value, R value is 0.48 and the p-value is very low. If we again go back again and look at question 2, we can see that question 2, the R value is 0.15, which is, we can call it a fair question. However, since the p-value is not significant, then this question also is not discriminating between high and low performing students and need to be remodified. Again, from this table on the bottom, we can say that question number 3 is a good question. Question number 4 is a very good question. Number 5 is a very good, if not excellent question. Number 7 is not a good question. Number 8 is a good question. Number 10 is a good question, and 11, 12, 13 I have described them. Number 14 is a very good question. Number 15 is a very good question, and number 16 I have the data for it, but it wasn't included in the tables. But again, number 16 here, it is a very good question, as the p-value is less than 0.05. So this is the way to use the power of the point biserial correlation coefficient to determine the R value and the p-value, and to look at the correlation between specific question and correlating it to the overall mark to determine whether the question is good or bad. Evaluating exam multiple choice questions and sorting them as either good or bad questions when designing an exam paper or sheet for students, and assessing those questions using the item discrimination analysis in first SPSS and then in Excel using the point biserial correlation coefficient. Good or bad MCQ questions. Whether you are an educator, a teacher at school, or a lecturer at college, or a professor at university, and you are frequently involved and participate in exam questions design, and you repeatedly design multiple choice question exam paper, and you want to look at the questions and determine which one of these questions are bad and which are good, which of these questions discriminate between the student of high performing student and low performing student. The way to do that is to use item discrimination analysis or question discriminating analysis in SPSS based on using a point biserial correlation coefficient. A point biserial correlation coefficient is a statistical test that is used to find the relationship between two variables or two sets of data. And I'm not going to describe the background and the criteria and the conditions in which to use the point biserial correlation coefficient in it, as I've already described it in a separate video, and I have uploaded that on my YouTube channel, and I'm going to leave the link for the video in the comment box, so feel free to have a look at it. But here I will just show you how to do the statistical test and how How can you tell and determine and identify a good question or a bad question? Here in SPSS, I have a data for an exam question for 38 students answering 76 questions, multiple choice questions. So we have here 76 variables, 76 columns, or 76 items. These questions can be called items also. And the score or the value for each question for each individual student answered is recorded as either 0 or 1. 0 stands for wrong answer. The student has or had answered the question wrongly, and 1, the student had answered the question correctly. And to determine which of those questions are good and which are bad, we need to do a statistical test called point biserial. But we need first of all to do 2 steps. The first step, we need to calculate the overall total mark for each participant or each student achieved. So we need to generate a column here for the total overall exam mark or total exam score for each individual student. So we are going to generate a column here for that, and we are going to calculate that in percentage. So we're going to add all the scores or the value for each of those 76 questions for each individual student, add them together, divide them by 76, and then multiply them by 100. The way to do that is to click in SPSS, to click on transform, compute variable. Again, there are 3 ways to calculate the total exam score or the overall exam mark. First one is you click on bracket, drag the first variable, click on plus, second variable plus, and then plus, and so on until you move all the questions in between the bracket from question number 1 to 76, and then divide that by 76 as we are adding them up, and then dividing them by 76, and then multiply them by 100. So this is one of the way to calculate the total exam score. The other way is to click on function group all, then scroll down to statistical, and then from statistical choose the sum command and drag it to the numeric expression. Again, you have the sum command and then a bracket, and we need to move the first variable separated by comma, second variable separated by comma, third variable separated by comma, and so on until you enter the 76 variables in between the bracket. Then you need to divide that by 76, multiply that by 100. So this is the second way. The third way, which I am going to use here, is to use the mean function. Again, so we need to generate a target variable. We're going to call that target variable over all marks. Overall marks, and again we're going to move all the scores, all the variables, all the items and with their score in them into the bracket one by one, separated by comma to generate the mean. So we have here 76 items or variable, and I had already type this in Microsoft Office, and I'm going to copy it from here. Right click and then copy, and then paste it into the in between the brackets, so to save me time, so they are there to use whenever I need them. So here we have the mean, and in between the bracket the variables or the items from question number 1 to question number 6. And to calculate the overall mark, i.e. the percentage, I need to multiply this by 100. As of already here, the average has been calculated. And if we click on OK, a new column is generated, or a new variable is generated, which has the overall mark or the percentage of each student achieved in the exam. So here now we have 76 variables and an overall exam marks. So, and we want to identify and determine which questions are good and which question is bad, using the point biserial correlation. So the next step is to do a point biserial correlation coefficient. Here, as we can see, we have these questions, and we want to find the relationship or the association between question number 1 with the score in it and correlating that with the overall mark. So to determine whether this question is good or bad, whether it is discriminative or not. And we need to do this for all the 76 questions together simultaneously. So each one by one, comparing each questions with the total mark. So we have here 2 variables. The first variable is the item or the questions, which is categorical because it only had a score in it 0 or 1, category 0 and 1, right or wrong, 0 wrong, 1 is right, and the continuous variable, which is the percentage. So here we can use the point biserial correlation coefficient. And the way to do that is to click on Analyze, scroll down to Correlate, then to bivariate, because we are all looking at here by mean 2, variate mean variable, 2 variables, and I'm going to reset this. Again, we have here the 76 questions or items, and we want to correlate each one individual one with the overall mark to calculate the point biserial value or coefficient. Click on Control A to select all the questions with the continuous variable and drag it into the variables. And we're not going to change anything here, keep it as it is, but we make sure that we use here the Pearson correlation coefficient test, as the point biserial correlation coefficient test is based on the point biserial is based on the Pearson correlation coefficient. If we click on OK, an SPSS will generate a correlation matrix for question number 1 to question number 76, correlating this intercorrelation between each items and correlating them with the overall marks. So we are interested in this column here, or sorry, in this row here at the bottom, and on the final column, which is titled as, labeled as overall mark. And again, if we look at the final row here, which says that overall marks, Pearson correlation, and then it's given a Pearson correlation value and significance of that value. Again, for which is again Pearson correlation represent point biserial. For point biserial correlation, the value is from -1 to 1 to +1. -1 indicates it's a negative relationship, and +1 it means a positive relationship, and the higher the value, the stronger the relationship. Again, and for purpose of analysis of this test, for the point biserial correlation, we set the value that anything below 0.15 value for point biserial, the question or the item is poorly designed, or a poor question, or a bad question. Anything above 0.25 is a good question, and anything higher, it is a very good question. However, simultaneously, we need also to look at the statistical significance. Anything below any value for p-value for the test below than 0.05, then it is statistically significant and the correlation value is significant. In the first example here, we can see that the correlation between question number 1 and overall mark is 0.22. That's considered to be fair question. However, it failed to be statistically significant, so we will consider that questions probably considered to be a bad question. Again, the same thing for question number 2. The p-value is 0.36, so it is less than 0.05. Again, this question is not statistically, the value for it is not statistically significant, so this question is also a bad question. However, for question number 3, the p-value is 0.029, which is less than 0.05, so it is statistically significant, and the correlation coefficient is 0.35. This is a really a good question that can discriminate between students. Again, a fourth question is 0.5. This is a very good value or coefficient, and the statistically significant. The fifth question is 0.7. The value for the coefficient is 0.76, and this is really a very high value. So this is really a very, very good question. And the sixth question here, as we can see, the point biserial correlation coefficient is very close to 0, so it's 0.054. Anything that is close to 0 or 0 is indicate that the question is not discriminating between students, so it is not a good question, so it is a bad question. Meanwhile, also the value for the statistical significance is greater than 0.05, so this question is really a bad question, and so on and so on and so on. So this is the way to determine which question is good and which question is bad. And if I want to save or export this table, which I'm going to do, and I'm going to export the data, the table or the outcome for the statistical analysis for the point biserial into either Excel file or Word documents or PowerPoint or even as a PDF. And I'm going to export this table here, the correlation matrix, as a Excel file. And the way to do that, click on the table and then right click on export, and then another window will pop up, and I'm going to select Excel 2007 and higher, and I'm going to call it again point biserial, saving it, and I'm going to keep the tick for open the containing folders once the file is exported. If I click on OK, it says that it already exists, so I'm going to overwrite it. So the file is exported into the Excel in a format of an Excel file which have the correlation matrix in it, and in this occasion I am only interested in this row. So what I'm going to do is I am going to select the rest and delete it. But I'm going to need, I'm going to keep the question number 1, but I'm going to questions or items, and I'm going to delete the rest. So I'm just only interested in the correlation between the questions and the total marks. Let's make sure that I have everything here set up correctly. So if I right click, select, and then right click and delete, and then click on OK, I will have here the correlation between questions and the value of the correlation and the significance. So I'm going to get rid of the first column and get rid of the last column, as it is the number only, and I'm going to rename this, instead of Pearson correlation, point biserial, as it is based on Pearson correlation. So I have here the point biserial for every individual questions in your exam paper, and I'm going to get rid of this column as there is no need for it. So we have the p-value and the value for the coefficient. So anything with statistical significance and a higher value indicate that the question is good, and anything below it is bad. Here there is an interesting observation. I need to mention it. In one of the data here, let me look for it, minus. There is a minus point biserial. Minus indicate that high performing students are answering the question wrongly, and low performing students are answering it correctly. So in this case there is something wrong with the question, and it's the best way is to remove the question and replace it by another question. So this is one of the benefits of doing discrimination analysis, item discrimination, using the point biserial correlation coefficient, as it will highlight the question, which question has problem in it, or which question is bad and which question is good. Again, I could also take this data here, copy all the 3 columns or just the 2 columns here. I'm not interested in the first. Copy, and then I had this data in a Excel file. I could also here I have it here somewhere in exam question. I could add it to the data I had already for this exam result, and I could add the Pearson correlation here at the end of the either in columns or in row, and I do prefer it in row here. Again, as for every question, biserial correlation, this is question number 1, and this is the point biserial value, and this is the significant value or the p-value for the question. So in this way, I had shown you how to determine which question is good and which question is bad based in exam, based on item discrimination and analysis using the point biserial correlation coefficient. Assessing the quality of multiple choice questions in an exam sheet by evaluating the ability of the MCQ or a question its ability to discriminate between a high performing student and low performing student, i.e. measuring the power of each individual questions in its ability to differentiate between good students and high quality students and low performing students based on evaluating each specific questions, whether it is a good questions or a very poor questions that probably require replacing or removing. The way to do that is to use an item discrimination analysis in Excel based on point biserial correlation coefficient. Again, this assessment of the questions is of a great benefit for those who are involved in education and designing exam sheets or paper, and to want to make sure that the questions serve the objective of their subject or taught modules in a way that it will fulfill the requirement for and it assess the learning objective of a module. So doing an item discrimination analysis is an important step in assessing exam questions, multiple choice questions. I have generated, as I said before, a video clip describing what is point biserial correlation coefficient and the background for it. For those who are interested, feel free to look at the video in my YouTube channel. Here in Excel, I have entered a data from an exam result for 38 students answering 76 multiple choice questions from question number 1, Q1 to Q76, and each individual or each student answered the questions, the data recorded or entered as either 0 or 1. 0 stands for wrong answer and 1 indicates correct answer. So each question has a value or a score of either a 0 or a 1 answered by each individual student. 1 for correct answer, 0 for wrong answer. So here in these questions we have only 2 types of scores, 0 or 1, which will indicate that it is a categorical data. So just 0, 1, 0, 1. And if we want to evaluate each questions and look at the quality of each multiple choice questions of those 76 questions, and the first step to do that is first of all to calculate the overall exam score for each individual student, or the total score that each individual participant had achieved in the exam. And the way to do that is to scroll here to the far right, and I'm going to generate a new column, and I'm going to call it total score. And the way to calculate the total score is to add up all the value or the scores for each individual participant has achieved for all the questions, 76 questions. Add them up, the value for them, then divide them by 76, and then multiply them by 100 to calculate the percentage of the correct answer or the total score, which we are going to use these scores in subsequent analysis. And the way to calculate that is if we just click on the cell here and then click on the symbol here indicate. We can use 2 methods here. either using the sum, adding up all the value, or use the average. And I'm going to use the sum method, in which I'm going to select the question number 1 to question number 76 as it's showing here, equal sign sum P2 to PY2, and I'm going to divide that by 76, since we have 76 questions, and then multiply that by 100. So the total score, or the percentage of the mark for each individual student for the exam, first one is 82. And if I select and drag the cell toward the end, it will autofill the total score for each individual participant or student. So here we have 76 questions scored as either 0 or 1, and a total score of 38 students, and the scores in a percentage. So here we have a categorical data for each one of these questions, 0 or 1, and a continuous data percentage from 0 to 100. And to determine which one of these questions is discriminative between students or not, you need to do a point biserial correlation coefficient. And point biserial correlation coefficient is based on Pearson correlation coefficient. And to do the analysis, we need two sets of data. The first set is dichotomous or categorical, as we have here the questions, and the second one is the continuous. So we need continuous, which is the total score. So we need to correlate and find the relationship between each individual question with the total score. So we need to study the relationship, calculate the relationship through a statistical test of point biserial between each individual question and total score, and to generate a value for the correlation, and this value indicates the strength of the relationship. And the way to do that in Excel is if we click on data and then click on the data analysis. By the way, if you don't see the data analysis icon on your Excel sheet, the way to bring it on is click on more and then go for options and then scroll down to add in, and then scroll down here to manage add in, and click on this analysis toolbar, which will make the icon appear here. So if we click on the data analysis, and then I'm going to, here we have a list of tools or tests to use, and we're going to select correlation, since we are looking at correlation, and this will use the Pearson correlation coefficient. If we click on OK, the window appears, and we are going to input the range. So we are going to correlate the data, the total score, with all the 76 questions. Then we need to click on this arrow, and I'm going to click here, then scroll to the beginning of the up to Q1, and then hold the shift key and click on Q1. Again, the data that we need to include is highlighted, and then click again on shift control and on the below arrow. This will select all your data that you want to correlate the total score with all the questions. And if we need to keep this label in the first row ticked in, and we're going to generate the correlation in a new worksheet. If we click on OK, again a correlation matrix is generated, as we can see here, in which each question, so you look at the bottom one here, each question is correlated with the total score. Total score correlated with the question 1 up to question 76. So now here I'm going to rearrange and delete the data that I don't want. So I'm going to get rid from this row up to 76. So by holding the shift key, click, and then right click on it in it. I'm going to select delete. Again, this will delete the other data that we are not interested in. So here what we have is the correlation between question number 1 and total score or overall mark, and question 2, 3, 4, and so on. And to rearrange the data in a much better way, we highlight this row, then right click on format the cell, and I'm going to click on number, and I'm going to use only 3 decimals to make the value here easy to compare. So here from this data we can see that we have the correlation coefficient for all the 76 questions, and each question has a value. I'm going to get rid of the last one because it's correlating total score with total score will be 1. So to delete this one. So now we have the value, the coefficient value, the point biserial coefficient value for all 76 questions. And in fact I want just to color code those value so that will be much easier to look at the data. So if I highlight the row for total score and then click on home and then click on conditional formatting, then click on new row, and in the new row I'm going to use a 3 color scale, and I'm going to change the type into number for all the minimum, the midpoint, and the maximum. And I'm going to enter here as a -1, since the range for the point biserial coefficient is from -1 to 1. So I'm going to keep the midpoint 0. The maximum 1 is here is 1, and I'm going to change the color. For the minus we need to make it red. For 0, which is, I don't want to make it white as it is, that indicate no correlation. And for the maximum 1, put the color coded with a green. If I click on OK, and here again color coded, all these cells are color coded again according to the value within it. As we can see here, that the higher the value, the more greenish the cell will be. As here the correlation coefficient is 0.76, and here is a poor correlation of 0.15, and here also a 0.05, and also interesting really toward a pinkish, toward reddish color, which is indicate a minus correlation, and here also a minus correlation. Now what does this value mean? This value mean that if you have a value of P, I'm going to call this point biserial, as this is the point biserial now, and then I'm going to make it a little bit darker. So what does this value mean? Indicate that the higher, the closer the value to 1, the stronger the correlationship between each questions and the total mark. So in this case, anything above 0.15 is a fairly good question, or anything from over 0.25 it's a good question, and anything over 0.4 it is a very good question. Any value close to 0, as here, it's indicate that there is no correlation between the question and the overall score, i.e. this question is not discriminative. It doesn't discriminate between high performing and low performing students. So this question needs addressing either by remodifying it, rewriting it, or excluding it and removing it from the exam sheet. A negative value here indicate a problem, as it is minus 0.294. This indicates that high performing students answered this question wrongly and low performing students answered the questions correctly, which doesn't make sense. So there is something wrong with these questions, and the best way for it is to exclude that question and remove it from the exam. And also similar things to this, also question number 70, as it's also negative. So negative mean it is a bad question. So it's to get rid of this, anything close to 0 or minus need to be removed, and as it doesn't discriminate between individual. So this is the way to discriminate between questions and find out which questions are good and which questions are bad, which questions to keep and to use in the future exam sheet, and which one to replace or rearrange or rewrite. Now, this value here for the point biserial, although it is, some of these values are high, but again this value has to be statistically significant, has to be confirmed by calculating the p-value. So p-value for each correlation between questions and overall score is need to calculate the p-value, as the p-value is the determinant factor in the significance of the relationship between the questions and the overall score. So to calculate the p-value for each individual questions, correlation of each individual question to total score, is to click on, if we go here again to this data and we want to calculate the p-value, I'm going to select some. Unfortunately in Excel we only can do it one by one questions by one, so we need to calculate the p-value for question 1 and then question 2 and then up to 70, question number 76. So I'm going to select question number 5 here and calculate the p-value for question number 5, as the p-value here for question number 5 is 0.76, which is very high, but is it significant? And the way to find out the significance is to calculate the p-value. To calculate the p-value for number 5 here, you need to click on the data, then icon for data analysis, then scroll down here on the list and use the regression. We are going to use the regression to calculate the correlation between these two variables to get a p-value. So if you click at OK, and in this window we are going to enter a data for y-axis input. In case it is a correlation, it is a regression, then you have y-axis and x-axis, and it's a correlation between them, and then calculating the p-value. For y-axis we are going to use the score data here, as it is selected total score, as this is the overall mark. And for the input, again we're going to select that, we haven't selected that. If I click on this here and then hold the shift control and down arrow, it will select just only the data and the label for that column. And we'll do the same thing for input. For the input X range, I'm going to calculate the p-value for question number 5. So I want to scroll to number 5, click on it, and then hold the control shift and then arrow indicating to the lower arrow, and then click on here again. As you can see that number 5, let's do it again, double check. So if we go for number 5 here, click shift and then black arrow is selected here, as we have seen here. 5 and arrow column 5 is selected, and then click on label, and we are going to generate the output in a new worksheet. If we click on OK, here a few tables are generated. What is important here in this tables is we need to look at just only the question number 5 here. I'm going to highlight that with the yellow color. And of all this, what is interesting to us is the p-value. This one, this p-value, as it is. Again, this video look like a little bit complicated, so we need to change the format of the cell to a much easier decimal point. Change it to 3 decimal point. Again, as we can see, this is the p-value correlating question number 5 with the overall mark, and the p-value for it is 0.00. So question number 5 here, if we go back again to the MCQs, question number 5, and here in this sheet, question number 5 has a p-value which is equal 0.000. So again, we need to set up this for the format of the cell into 3 decimals. So we need to see the decimal. Click on OK. I see the decimal. So this question number 5 is really an excellent question. First of all, it has a high value for the correlation coefficient, 0.76, away from 0 toward 1, and a statistically significant p-value, which is 0.000. And for the p-value, for anything to be statistically significant, the p-value has to be less than 0.05. This is the cutting point. Anything less than that, then the value we are looking at is significant. So it is significant or important value. Anything below 0.05, this is significant. Then this value of 0.76 is a significant value, which means that this question number 5, is a very good questions, a very excellent questions to keep for discriminating between students. I will also look for another example here, and I'm going to look at question number 6. As we can see here, the correlation value is 0.05, which is close to 0, which might indicate that this question is a bad question. Again, we need to calculate the p-value for it, as without p-value we cannot really make a conclusion on the quality of these questions, as the value for point biserial by itself is not enough to judge without the p-value. So we need to find out the p-value, and to find out the p-value, again we go to the MCQ, the sheet, original sheet, or data. It has data in it, and then data analysis, and then regression again. And we are going to use keep y axis or input y range as the total score, and the x range we're going to select number 6. If I select, then Control Shift and below arrow, and then click on here, click on label, keep it as it is, and click on OK. Again, another regression tables is generated. We have to do again the same changes. Change this into, format the cells, change it into 3 decimal points. The p-value is 0.79. If we copy this and we go here to this 0.7 and place it here, 0.749. Again, if we look at the p-value for here it's very high. It is above 0.05. So once we see this value here, so we have to reject this value, this reading or this value from correlation coefficient, and we say that this questions is poor questions, and we should not consider this questions in the exam, as the correlation is very low and at the same time it is non-significant. Now, one last point before finishing, I want to pick up a negative question. I'm going to do the same thing for negative question. Here for question number 47, we have a correlation coefficient minus, which indicate that the question is not discriminating, as in this question, high-performing student answer this question wrong, and low-performing students answer it correctly. So we need to find out whether this question is worth considering. Again, if it is minus, then it does not worth considering, and it's worth removing it. It is important to remove this question as it is not discriminative. But again, we had to determine the p-value for this correlation value, which is minus 0.294, and the way to do that again is to go to the MCQs and then click on data analysis, regression again, changing that into selecting now the data number or question number 47, click, Control Shift, below arrow, and then click on OK. Again, another table is generated here, and as we can see here, the value, again changing these things into formatting the cell, so making it 3 decimal points, copy MCQs, and going to our first sheet here, and we're going to place the value here. Again, this is the p-value for this test when we correlate question number 47 with overall scores. It gave us a minus 0.29 value and a p-value of 0.07. Again, this value is greater than 0.05. So in this case, we discard these questions, as the correlation is not significant, and it is essential to remove this question from the exam. And again, you have to do these steps one by one for all the rest of the questions. You need both the value for the coefficient and the p-value to make your judgment on the question. So this is the way to do the analysis item called item discrimination or question discrimination analysis, to discriminate analysis that will discriminate between high performing and low performing based on the questions, evaluating the questions using a point biserial correlation coefficient value with a p-value for it, statistical significant value for it. So this is the way to judge whether a multiple choice question is a good or bad question, and this can be of a tremendous benefit to those who are involved in education and assessment and designing exams that is of a high quality and high standard one. Item difficulty analysis for multiple choice exam questions to determine the p-value, the proportion or the percentage value using both SPSS and Excel. Item difficulty measures the percentage of students who answered multiple choice question item correctly. It is frequently called the p-value, proportion or percentage value, the item difficulty value range between 0 and 1. The item difficulty reveals whether an item is too easy or too hard. A higher percentage item difficulty indicates an easier item, and a lower percentage item difficulty indicates a more difficult item. Value of 1 indicates very easy question, and value of 0 points to a very hard question. An item with a p-value of 0 or 1 does not differentiate between students who know the subject and the material and the content and those who do not. In this case, if you have an item difficulty for a question that is 0 or 1, delete that item from the exam or exams that are either too easy or too hard. And an ideal question has an item difficulty value between 0.4 and 0.6. The way to calculate the item difficulty is to use the following equation. Count the number of students answering item correctly, divide that by the total number of students, then multiply the product by 100 to generate an item difficulty. The table below classify the questions according to the value of the item difficulty. An item difficulty with a value range between 0 and 20% is considered as a very difficult question. A question with 21 to 40% range is a difficult question. An item that has 41 to 60% range value is considered as a moderately difficult question. And any question that has a range of 61 to 80% considered to be an easy one, and an item or a question that has a p-value greater than 81% considered to be a very easy question. So these are the criteria to classify question based on the item difficulty value. In this table shows 15 multiple choice question answered by 10 students, and the answer was recorded as 1 for correct answer, 0 for wrong answer. And to calculate the item difficulty or the p-value for each question, add all the correct answer scored for each questions and divide that by the total number of students. For the first case, it's 5 correct answer divided by 10, so it is 0.5. And for the question number 15, 2 correct answer divided by 10 is 0.2. Again, from the p-value for each item or each question of these 15 questions, the questions can be labeled as either easy or difficult or acceptable. For the question number 1, the p-value is 0.5, so it is an ideal question within the range for moderately difficult question. The question number 2 and 3 is they both have a p-value higher value of 0.7, so that indicates that these questions are easy, and they are easy questions and need to be remodified or readjusted. Question number 4 to question number 11 are up to 11 are an idealistic questions. Question number 12 is a very easy question, as 90% of the student answered the question correctly. And for question number 15, only 2 students managed to answer the question correctly, so it is a very hard question. So this is the way to classify items or questions in an exam that contain multiple choice question is to calculate the item difficulty. Item difficulty analysis in SPSS and Excel for multiple choice question exam to determine the p-value for each question and to identify questions that are easy and questions that are difficult based on the equation given below. Item difficulty equals to number of students answering item correctly divided by the total number of students multiplied by 100. Item difficulties measures the proportion of students who answered a question or an item correctly. Sometimes it is referred to as a p-value. P stands for proportion. The item difficulty value range from 0 to 1. 0 indicates that no student has had answered the question or the item correctly, so it is an extremely difficult question. And item difficulty of 1 means that all the students had answered the question correctly, so it is a very easy question. And the way to calculate the item difficulty is to count the number of the student who answered the item correctly and divide that by the total number of students participating or taking the exam. And to get the percentage, multiply that by 100. Here I have a result of an exam or a test for 38 students who had answered 76 multiple choice question, and their score was entered as 0 or 1, 0 for wrong answer, 1 for correct answer. And to calculate and determine the item difficulty for each question and to determine which question is very easy, which question is very difficult, which item is ideal and acceptable, we will follow the formula just described previously. So I'm going to type in this cell p-value as we're going to calculate the p-value or the item difficulty. And to calculate the item difficulty, I'm going to insert the equal sign and then type sum and then select the sum function and then select the range for the first question. So we are going to select the scores for item number 1 for student 1 up to student number 3 and 38. And then we close the bracket, and then we're going to insert also a bracket between the sum and its range. So as we are going to divide the sum by the number of the total number of the student participating in the exam, which is 38. So this the formula or the equation, adding all the value on the for the items for each student, their score, whether it is correct or wrong, and then divide that by 38. And if we click on the enter button or enter icon, the item difficulty value is calculated. To reduce the decimal, I'm going to select only 2 decimal points for this value. For the first item or questions, the value for the P is 0.18. And to autofill and auto calculate the item difficulty for all the remaining 75 multiple choice questions, select and drag so that toward the end of the column, that column ends for question number 76, and the Excel will auto calculate and fill the item difficulty for each question. Again, we can see here that each question has its own way of measuring its difficulty through item difficulty. To make things much easier, also I'm going to color code those values using the table here, small table, taking in consideration that the ideal question that has a difficulty, item difficulty range from 0.4 to 0.6, and I'm going to increase it a little bit here, taking a value of 0.4 to 0.66. So to color code these values, select the row first and then click on the conditional formatting, scroll to new rule, and then in the select rule type, click on the format only cell that contain. So in this format, I'm going to color code only cells that has specific value. So cell value, I'm going to use a range between 0.4 and 0.66. So what I'm going to do here is color code anything between 0.4 and 0.66, and I'm going to give it a color by clicking on format and clicking on fill. And since this is what we want to select, I'm going to click on the green color. And if I click on OK again and click here on OK, all the values that has a range between 0.4 and 0.66 is color coded as green, and green indicates that this is an ideal question. This is a question that is really good to use in the exam. Now for the rest, which is of course the rest will be either very easy or very extremely easy or extremely difficult. Again, we're going to do the same. Click on conditional formatting, scroll down to new rule, and then click on format cells that contain. Again, the same thing. Instead of selecting between, not between, so we're going to use exactly the same value, 0.4 and 0.66. So any value that is not between 0.4 and 0.66, we're going to color code that by clicking on the fill and give it a red color, meaning that this question is either it is very, very easy or very, very difficult. Click on OK, and then click on OK again here. As we can see that each item has its value for difficulty, and each difficulty is color coded: red for very easy or very difficult, and green is an ideal or acceptable questions with acceptable difficulties. To calculate the percentage of item difficulty, insert the percentage and then into the cell next to it, going to insert the equal sign and then select the value of the item difficulty for question number 1, multiply that by 100 and press on enter. A percentage of the item difficulty is calculated, and I'm going to decrease the decimal point to just 1 decimal point. And to calculate the percentage of item difficulty for the rest of the multiple choice question, just select, drag to autofill and auto calculate the value for the rest of the questions. Again, here the percentage of item difficulty is calculated with the p-value for each item. Here on this side, a small description for the range of the item difficulty. Any item or questions that has a p-value or item difficulty from 0 to 20 is labeled as a very difficult questions. From 20 to 40 is difficult. From 41 to 60 considered to be moderately difficult. 61 to 80% is easy, and 81 to 100% is considered to be a very easy question or an item. If we look at the item difficulty percentage for question number 1, we see that the value is 18.4%. Using the value here, a range of the value, this question is very difficult, as only 18.4% of the students answered this question correctly. So this question is extremely difficult one. And question number 2 next to it has a value for item difficulty of 95, nearly 95%, which indicate that 95% of the students participating in the exam answered this question number 2 correctly. So this indicates that this question is extremely very easy question. The one next to it is just on the border between an ideal question. Ideal question has a p-value range of 0.41 to 60, as shown here, 0.41 to 60. So this one is just on the border of being considered to be an ideal question. The one next to it is nearly 79% item difficulties, which indicate that this question is a very easy question, and so on. So we're looking at analyzing the item difficulty for the rest, and looking at this one here, saying it's 57%. That's an ideal question. The one here, 81, is very easy. This one is an ideal question. So this is the way to sort out and label the questions in an exam paper as either very easy, ideal questions, very difficult or difficult questions, based on the item difficulty calculation. Item difficulty analysis in SPSS is one of the methods to evaluate the quality of multiple choice question exam. Item difficulty measures the proportion of students who answered the question correctly. Sometimes it is referred to as p-value, stands for proportion or percentage value. Item difficulty value range from 0 to 1. 0 means that no student had answered the question correctly. So the question is an extremely difficult one. And an item difficulty of a value of 1 indicates that all the students had answered the question correctly, and the question or the item is an extremely easy question. The way to calculate the item difficulty value is to count the number of students who answered the question correctly, divide that by the total number of students participating in the exam, and then multiply the product by 100 to get the percentage or proportion of the value for item difficulty. Here in this sheet of Excel, I have an exam result for 38 students answering 76 questions, from question number 1 to question number 76. Those are multiple choice questions, and each question, the score for it was either 0 or 1. 0 indicates wrong answer, 1 means correct answer. And to determine which one of those questions is an easy and which one is a difficult, then we need to perform item difficulty. First, we need to copy these data and transfer it into SPSS to do the analysis in the SPSS. So to do that, click on the question number 1 and then drag and then scroll to the end toward question number 76. Hold 76, hold the shift key and click, and those questions from 1 to 76 are highlighted. Then click on shift together with control and with the arrow that's heading toward the bottom, and this will highlight the data that we want to transfer. Once these data are highlighted, right click and then select copy and then transfer this into SPSS. In a new window of data view, click on this cell and then right click and then paste the data from Excel into SPSS. And here I'm going to do a few editing and modification. I'm going to delete the first row, and if we look at the variable view, we need to do some editing for the changing the type of the data and lining the data and the measuring for the data, and also naming the variable. We'll start with the type. So since we have here a value of 0 or 1 or a score of 0 and 1 for each question, then we need to change this from a string into numeric. And the way to do that is you click on the cell here, 3 dots appear, click on them, and then a window appear here specifying what type of variable you want to select. So for this we're going for numeric. We click on OK, and we do the same for the rest and so on. So I've missed the first one, so I'm going to also change the type to numeric. And since once we started here, we can also select the cell and then copy and then select the cells that we want to change the type, highlight them, then right click and then paste. All these cells has been changed to a numeric. Now for the align, again you click in the align, 3 options appear. I'm going to make it center. For the second one also center. For the third one also center. And to make it faster, I'm going to copy the first one, highlight and select all the one that I want to change, and then paste to make them all center. And for measure, again we're going to keep it as scale at this stage. Now for naming of the variables, they are all named from variable 1 to 76, and I'm going to change that naming. So if we highlight that column here, all the variable, and then click Control F for replace, find and replace, a window will appear for find and replace variable. And in the find, I'm going to type VAR000, and then I'm going to replace anything with VAR variable 000 with Q for question. And I'm going to do that for all the variables. So we replace all the variables. So we click on replace all, and as we can see here, all the variable name has been changed into Q number 1 to Q number 76 with the 38 cases. Now we are ready to do item difficulty analysis straight away. The way to do that is to click on Analyze, scroll down to Descriptive Statistics, then scroll down to Descriptive. In the descriptive, we are going to calculate the item difficulties for all the questions. So we're going to select all, Control A, and then drag into the box of variables. Under the options, click on the options and take the minimum, the maximum, the standard deviation, and keep the mean, because the mean in this case is the total amount of the correct answer divided by the total number of students participating in the exam. So the mean reflects here the item difficulty. So click on continue and then click on OK. The SPSS will generate an output, a table from question number 1 to question number 76. And in this question there is a mean for each question, which is the average of the correct answer for every individual item or question. So this is the value here is the item difficulty or the p-value, and it could be changed into percentage by multiplying it by 100. As a standard rule in calculating and evaluating item difficulty, any item which has a value for item difficulty between 0.41 and 0.6 is considered to be an acceptable, an ideal, and a moderate difficult question. Anything below 0.41 and or higher than 0.6 is considered to be either a very difficult or a very easy question. So here for the question number 1, the item difficulty is 0.18, which means 18% of the student answered this question correctly. So it is a difficult question. In fact, it is a very difficult question. The question number 2 has a value of 0.95, or 95% of the student answered the question correctly. So this indicates that the question is extremely easy question. Question number 3 had a value of 0.39, just on the border of 0.41. So we'll consider that as an acceptable question. Question number 4 has a value of 0.79, 0.8, 80%. So this indicates that this is an easy or extremely easy question. Question number 5 has a value of 0.66. Again, this one will be included in the category for moderately difficult question. So we'll accept that as an acceptable question. So if you scroll through all, we can see here there is 92% of the student answered the question correctly. So this is the way to identify and determine which question is an easy question or extremely easy question, and which question is an extremely difficult question or a difficult question. And so this way an examiner will be able to identify the question, modify them or change them, and make the exam quality of a high standard for the students. And to transfer this table, I'm going to export this table into Excel and save it as an Excel file. And the way to do that is to click on the table as it's highlighted in yellow, and then right click on it, and there is a function for export. Click on that export, and I'm going to export that table into Excel, which is 2007 and higher, and I'm going to save that in the folder for YouTube under exam questions, and I'm going to save it here as item difficulty. Choose the item difficulty here and save. Item difficulties, and I'm going to save it in under item difficulties, and then if we click on item difficulty and save it here, and then we made sure that this box for open the containing folder is ticked on. If we click on OK, again it will be exported and the file is saved in item difficulty in the folder.